In this video, I will be explaining how to assign R and S absolute configurations to a chiral molecule with multiple bonds. I will use this example to explain this concept. The first thing to do is to identify the chiral center. The chiral center in this molecule is going to be this carbon. That's because that carbon has 4 different groups attached to it. The groups are the amine group, the third butyl group, the 2-chloroethyl group, and the vinyl group. After identifying the chiral center, we need to convert the double bond in the vinyl group to single bonds. I will take a few moments to explain how to convert multiple bonds to single bonds. In this example, how can you convert this carbon-carbon double bond to single bonds? There are 2 bonds between the 2 carbon atoms, 1 sigma bond and 1 pi bond. Break the pi bond into 2 and attach 1 bond to each of the carbon atoms. Then attach the red carbon to the blue carbon bond and attach the blue carbon to the red carbon bond. This is how you convert a carbon-carbon double bond to single bonds. Let's take a look at another example. How can you convert this carbon-nitrogen double bond to single bonds? There are 2 bonds between the carbon and nitrogen. The bonds are 1 sigma bond and 1 pi bond. So break the pi bond into 2 single bonds, attach 1 single bond to the carbon and another single bond to the nitrogen. Then attach the nitrogen to the carbon bond and attach the carbon to the nitrogen bond. This is how you convert a carbon-nitrogen double bond to single bonds. Let's take a look at another example. How can you convert this carbon-carbon triple bond to single bonds? In this triple bond, there is 1 sigma bond and 2 pi bonds. So first, break 1 pi bond into 2 and attach them to both carbon atoms. Then attach the red carbon to the blue carbon bond and attach the blue carbon to the red carbon bond. Now we have 1 pi bond and 1 sigma bond. So break this pi bond into 2 and attach them to both carbon atoms. Now attach the red carbon to the blue carbon bond and attach the blue carbon to the red carbon bond. This is how you convert a carbon-carbon triple bond to single bonds. Having shown how to convert multiple bonds to single bonds, let's go back to our original structure. In this structure, we need to convert the carbon-carbon double bond to single bonds. To do this, break the pi bond into 2 single bonds and attach the single bonds to both carbon atoms. Then place this carbon on this bond and this other carbon on this bond. After converting the double bond to single bonds, the next step will be to list the atoms in each of the 4 different groups, starting with the atom directly attached to the chiral center. Let's start with the amine group. Since nitrogen is directly attached to the chiral carbon, the nitrogen will be listed first. We will then list the 2 hydrogen atoms that are attached to the nitrogen subsequently. Let's consider the third butyl group. In the third butyl group, the blue carbon is directly attached to the chiral carbon. Therefore, the blue carbon will be listed first, followed by the 3 red carbons that are connected to the blue carbon. Next is the 2-chloroethyl group. In the 2-chloroethyl group, the blue carbon is directly attached to the chiral carbon. Therefore, the blue carbon will be listed first. The atoms attached to this blue carbon in decreasing order of atomic number are the red carbon, followed by the two hydrogen atoms. The last group would be the vinyl group, which has now been converted to single bonds. In this vinyl group, the blue carbon is directly attached to the chiral carbon, therefore the blue carbon will be listed first. The atoms attached to this blue carbon in decreasing order of atomic number are the red carbon, another red carbon, followed by the hydrogen. After listing these four different groups, we will then rank the groups from 1 to 4, with 1 being the highest priority and 4 being the lowest priority. We can determine the priority numbers by comparing the first atoms in the four different groups with one another. The atom with the highest atomic number will get priority number 1. The atom with the second highest atomic number will get priority number 2. The atom with the third highest atomic number will get priority number 3. And the atom with the lowest atomic number will get priority number 4. If the first atoms are the same, we will go to the second atom and keep going until there is a difference. If we compare the first atom in each group, nitrogen will get the priority number 1 because it has the highest atomic number in this first column. Therefore, we will assign priority number 1 to the amine group. In order to determine which group gets priority number 2, we will compare the other first atoms here. However, since these are all carbon atoms, there is a tie, and to break this tie, we will go to the second atoms. All the 3 second atoms here are also the same. Again, there is a tie. And to break the tie, we will go to the third atoms. Here, there is a tie between these 2 carbon atoms. So this means one of them will get priority number 2 and the other priority number 3. So to break this tie, we will go to the fourth atoms. Since carbon has a higher atomic number than hydrogen, priority number 2 will go to the third butyl group. Priority number 3 will go to the vinyl group. And priority number 4 will go to the 2-chloroethyl group. Next is to redraw the structure by replacing all the 4 different groups with their respective priority numbers. Since group 4 is on a wedge bond, we will ignore group 4 and draw an arrow connecting groups 1, 2, and 3, then assign configuration based on the arrow direction, and simply change the configuration obtained to its opposite. So now let's ignore group 4, then draw an arrow connecting groups 1, 2, and 3. This will give us a clockwise direction and an absolute configuration of R. So invert or change this configuration, and we will have an absolute configuration of S. Therefore, the absolute configuration of our molecule is S. In order to help other students benefit from this video, please subscribe to this channel, share and like this video, and leave a comment in the comment section.